Hey, what's up? It's your old pal, Mr. Cook, and we're going through the probability review. We just got done with the first page, the front and the back on it. Now we're working on the second page, so starting off with number 9. Okay, so Hap is trying to find a matching pair of socks. Hap? It's an interesting name. He has 12 white socks, 3 black socks, and 14 blue socks in the dryer, and he will draw one sock at a time. So are these events independent or dependent? So as long as he doesn't put the sock back in the dryer, these are dependent events, because when he takes the sock out, there's one less sock in there. So the likelihood of getting any individual sock is less each time. So the probability's changed. What's the probability he draws 2 blue socks? All right, so let's start with that one. 2 blue socks. So there are. Let's see here. Let's see the total number of socks. There's 12 plus 3, which is 15. 15 plus 14 is 29. So there's 29 total socks at the beginning, and there are 14 blue socks. So he has a 14 and 29 chance of getting out a blue sock on the first try. Now on the second try, for the second sock, there's one less blue sock in there, so there's 13 blue socks. And there's one less total socks if he takes that blue sock out of there. So there's 28 of those. And then all you got to do is just multiply the two together. So let's see here. 14 and 28, those reduce. And then 13 over 58. So 13 over 58 would be your answer for that one, when it's all like reduced and stuff. What about 2 black socks? Well, all right, so there's 3 black socks at the beginning out of the 29. And then if you take one of the black socks out, there's 2 of them. And if you take out one of the black socks, that also takes down this one, so that'd be 28. So then if you reduce this down a little further, that'd be, oh gosh, let me just use my calculator for this. 3 out of 29 times 2 out of 28, and then change it to a fraction. So 3 out of 406. So there's the probability for the 2 black socks. So blue socks and black socks. What's the probability that he will draw out a white sock and then a black sock? So getting out a white sock first would be 12 out of 29. And then he gets rid of that white sock, but there's still 3 black socks in there. And there's one less total sock, so that'd be 28. All right, so now let's multiply those together. 12 over 29 times 3 over 28. And then change it back to a fraction. And you get 9 over 203. And there we go. That's our probability for those 2 events. Okay, next, a grab bag contains 12 baseball cards and 8 superhero cards. An experiment consists of taking one card out of the bag, then replacing it, and then selecting another card. So this makes the events independent, because since you're putting the card back in there, it doesn't change up any probabilities. So then that's if you're replacing it. So what's the probability of selecting a baseball card? So there are 12 baseball cards out of the total of 20. And then a superhero card. So you're replacing it back in, so you still have 20 cards in there. And there's 8 superhero cards also. So if you just multiply those together, let's see what we get. So 12 over 20 times 8 over 20. And change it to a fraction. So that'd be 6 out of 25. All right. What's the probability of selecting 2 superhero cards? So there's 8 superhero cards, so you'd have an 8 in 20 chance. And then if you replace the card back in, it's still going to be 8 out of 20. So you just multiply those 2 together. Let's see what we get. 8 out of 20 times 8 out of 20. And then change it to a fraction. So that'd be 4 out of 25. So those are our 2 probabilities so far. What's the probability that you don't select 2 superhero cards? So this is using like that same kind of idea that we had on number 5 of like getting rid of the probabilities. So we just had the probability of like getting 2 superhero cards, 4 out of 25. So what we would do is just subtract that away from all the possibilities, which is 100%. So 4 out of 25 subtracted from 1 out of 25, or 1, would give you, let's see here, if I use my calculator, 1 minus 4 out of 25, and then change it to a fraction, you get 21 out of 25. So that's the likelihood of that. You can find it individually if you want, but you'd have to find 3 separate probabilities, because what's the probability you don't select a superhero card? So that means that you get a baseball card, so a baseball card, and then a baseball card after that. So you'd have to find both of those. And then you'd add on getting a superhero card and a baseball card, because that would just be one superhero card. And you'd also have to find the probability of getting a baseball card and then a superhero card. And then you'd add all those probabilities together, and that'll still give you the same number, which is 21 out of 25. So 2 different ways to get it. All right, let n be a random integer from 1 to 60. What's the probability that n is even, given that it is greater than 20? So if it's greater than 20, then that means that we've got, like, you can write out the sample space if you want for this. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, and 60. Okay. And then, so what's the probability that n is even? So we just did the given part of it, so we know that's greater than 20. And what's the probability it's even? So let's count up the evens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 of them? Out of how many numbers? So how many do you think there's going to be? I mean, you can count them up if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Sure enough, 40. And then 20 out of 40 reduced down to 1/2. And of course, you could have just, figured that out yourself, because the numbers are either going to be even or odd. There's no other choice. So it's like 1 in 2 chance. But you could also do it that way if it's a little bit more complicated. All right, number 12, Elena chooses one of 50 tiles numbered 1 through 30. Let A be the event that the number is odd, and let B be the event that the number is a multiple of 3. So you could kind of do the same thing here. It sucks that it's, 50 tiles. Wait, that doesn't make any sense. Let's choose one of 50 tiles numbered 1 to 30. I think that's supposed to be 30, not 50. So let's just change that little typo. Okay, so let A be the event that the numbers are odd. So let's write out A. So the odd numbers from 1 to 30, that to be 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, and 29. So those are all the odds, 1 through 30. And then let's also list off B. So B is the event that it's a multiple of 3. Multiple of 3 means that it's like, if you take 3 and you keep multiplying, like 1, and then times 2, and then times 3, what numbers do you get? So 3 times 1 is 3. 3 times 2 is 6. 3 times 6, 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. And then 3 times 8 is 24. 3 times 9 is 27. And 3 times 10 is 30. All right, so there's all of our options for B. So we need to find this conditional probability. So this says that what's the probability that you have an even number given that it's from B? So we're only dealing with the numbers in B. So that's how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 numbers. And of those, how many of them are A, which is even? So which ones of these are even? 1, 2, 3, 4, 5 of them. So 5 out of 10 reduces down to half. So that's the probability, 1 over 2. Now what's the probability of getting B, which is a number that's a multiple of 3, given that it's A, an even number? Or I'm sorry, an odd number. Whoa, wait, did I get that wrong? Odd number? Oh, shoot. Sorry about that. So A is that it's odd, so it'd be 1, 2, 3, 4, 5. So it's still 5 out of 10. So we're still good on A, the answer, but I just wanted to verify that's the odds, not the evens. That's my bad. I just misread it. All right, so yeah, anyways, back to number 12B. So we start off with the group A, so that's these numbers, and we need to find out which ones are B, which are multiples of 3. So which are the multiples of 3? We've got 3 and 9 and 15 and 21 and 27. So that's 1, 2, 3, 4, 5 out of how many? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 15. And then that reduces down to 1/3. So you have a 1 in 3 chance of picking a multiple of 3 if you're just looking at the odd numbers. All right, so that's numbers 9 through 12. That'll be it for this page. So let's go ahead and stop the video here as well. And then we'll just continue on with the last part of the review, the fourth page.